Well, as far as an intro goes for me, so I'll describe one thing that I think is a problem that I have with most globe believers, but certainly McToon is one of them and many others. The problem that I have is that, and I described it to McToon recently too. I said, it's as if we see somebody robbing a bank, right? We see this guy, he's running out of the bank. He's got his duffel bag full of, who knows what, right? He's got his ski mask on, and I point out and I yell across, hey, that guy just robbed the bank. And out of the pub or whatever comes McToon and Simon Dan and Red's Rhetoric and all the other Globers together. And I say, guys, that guy just he just robbed that bank. Let's get him. And it's as if you guys all ran over there and said, excuse me, sir, did you just rob that bank? And the guy's like, no. And then they turn around and say, Jaron, you're such an idiot, man. Of course you didn't rob the bank. We just asked him. Well, that's what it's like, because what you guys do is simply go to the people that we say are lying, go to the people that we say are deceiving you, and get their answer, which is, of course, going to be a cover-up for whatever the deception we're saying is. Let's say that, for example, that it is a deception. Then you guys are the worst at actually uncovering anything. You're the least skeptical people I've ever known in my life. You're not skeptical of anything as long as it comes from science. There's no skepticism. So it's hilarious to me that the people that are supposed to be skeptical, for instance, when we had the 24-hour video of the sun from Antarctica, and you guys brought it to us as evidence. Here it is. Here's the evidence. Well, we had to point out to you that it was looped, that it was altered. None of you guys found that. We found it. So if it wasn't for flat earthers, you guys would just be accepting anything that floats your boat, anything that pre-confirms or, gives you what you've been looking for. So I don't think that really globe earthers are truly looking for the truth. They think they already have it. They've already said before that, people that are intelligent don't go looking for answers to questions or to questions or to answers that they already think they know, right? So it's not as if MC Toon watches one of my videos or somebody else's and is actually trying to learn. What he's doing is watching it for joke quality, looking for things that he can poke fun at. There's no actual investigation going on at all. If any, it's to go and reconfirm something that he already believes. So, we don't believe that spectroscopy works. Okay, well then he goes and grabs a paper and then brings it back, which is not impressive to anyone, at least to me. And I used to think it was impressive. I used to think that people that went to school and got it in college education were impressive. And I guess look at them as impressive as they stuck with it. They did the hard work when many of us just bailed. We didn't see the light at the end of the tunnel. So we just got out. It wasn't a matter of weren't smart enough. I think if you went through and looked at people that dropped out of college, it doesn't necessarily mean they're not smart enough. It just meant that they weren't willing to regurgitate, to do the extra work, to do work that seemed mundane, to do work that seemed unimportant. And some people were yes men. Some people were absolutely okay with doing anything that the teacher asked them. And this is the world that we live in, where you get promoted. You get straight A's. You get to become a professor. You get to become a dean. These are the people that move on, because you do whatever you're told and believe whatever you're told to believe. So one of the things we always get is, what are your credentials? Jaron, what are your credentials? Show us your credentials. Well, thank God I don't have credentials. If I had credentials, if I went to college, I would believe what you guys do, because the point of college is to indoctrinate those people. Now, it's an easy thing to see that if you were elite, if you were upper echelon, you had power, you had money, you would never sit around a table and say, let's think of how we teach children to be smarter than us, to come and take our money, to take our power. That's ludicrous. And that's what you have to believe. What makes much more sense is they would sit around and say, how do we dumb these people down? How do we make sure that our money is never jeopardized, that our power is never compromised? And the way you do that is through an education program that makes tax-paying slaves. It makes people complacent. It makes people go along with whatever the mainstream is. We're at a point in the world now where people are afraid to speak out against anything that isn't mainstream. They don't want their YouTubes canceled. They don't want their social medias canceled. So I know it's kind of a weird intro, but my goal here today is I want to start the conversation on some topics that I think should be handled, meaning you have a glober and you've got a flat earther coming together. If we can actually make some headway, if we can actually say, isn't this true? And we both can agree and we can move forward, then we're getting somewhere. And anybody who's been watching this debate, for the last 8 years, whatever it's been, knows that there isn't any of that. There isn't ever a moving forward. There's never a concession. It's as if both sides are just yelling at a wall. And it's pretty ridiculous, and I don't want to do it anymore. All right. 5 minutes for you, my friend.
All right. This is just the intro, right?
Yeah, just a little intro.
So, well, I have been interested in this topic for over 5 years. And when I first heard of it, I'm like, that's a bit strange. But it was one of your debates was the first. Yours and Red's was the first, I think, debate that I ever experienced. And when I got into this, I said, well, I don't want to be, right. Red's is a great guy, but I didn't want to be the vulgar guy. I didn't want to be rude. And so when you said you didn't, when you had interactions with the Reds, they went a certain direction. I see that happened. And so when I came into this, I thought, I'm not going to be that. So I'm glad that we've been able to talk. And however we had, hopefully this goes well. Concession, I want correctness, right? I want accuracy. So conceding something that's not correct isn't something that I would be interested in. I want to get to the correct understanding of something. And so if I need to concede to something, if I was wrong, absolutely. My wife says often, you always think you have to be right. And I know better than to say this back, but yes, right? She's not here. Yes, I do think I always need to be right. And if I find out that I'm wrong, I'm going to instantly change my mind so I'm right. So if I'm wrong about something, definitely I want to know about it and I want to fix that. So that's what I really hope to do. So I see your point and I see how you went into this. I myself, when I first started, took some of these things to heart and said, yeah, I did not personally test some of these things. Since then I have. So I can say and I can show what I've done. I'm currently still borrowing this P1000 from Joe Hill. This is his P1000. So I had a meetup last night. I invited him to come. He couldn't make it. I would have maybe returned it to him because I've had it for several months now. So yes, I've done the things with that at the ocean. I live in Minnesota, far from the ocean, but I on vacation have gotten down to Florida, and Alabama. So I've done some things there. So I don't know. I don't have a whole lot more. There you go.
Okay. Good. And then we were supposed to do the topic, right? So this is basically just a back and forth. And I think, if I remember right, what I sent you on a topic, we'll start with, I'll just start with hypocrisy or with claims that we're being deceitful when I don't think that that's at all the case. So, for example, I was watching, and I can bring up the video, but you might recall, you were covering Caleb and Derek's presentation at the summit. And at one point, they say the 66,600 mile per hour. I'm sorry, just set the clock back up. What is this, 5 minutes also?
Yes.
I think so. They were saying 66,600 miles per hour, and then you said, "Oh, when any flat earther says this, they are just taking some random number. It could be that it was traveling between different speeds. You said if you went to the store going 66 points, you were going 70 miles per hour, but at some point you went 66.6 miles per hour. So you equated those two things, which is a joke, because obviously if you take the 93 million mile orbit of the Earth and you plug that into any circle calculator, you're going to get 584 million for the orbit. You take the 584 and you divide by 365.25 and then divide that by 24 and you get 66,600. So that's not being deceptive. That's you being deceptive and pretending that doesn't exist. We didn't make that up. We're not just saying 60. Oh, it just happens to be. No, that is the average speed of the Earth around the sun. Simply taking the 584, and I don't know what it comes out to if you do a circuit calculator with that, but I can do it right now if we want, just to see what it comes out to. So I'm doing circle calculator, and I would be shocked if it wasn't exactly 66.6. I mean 66,600. Now I don't know what the numbers that come after that are. Circle calculator. So we're doing a radius of, let's just do a diameter of, no, let's do radius of 93 million. 1, 2, 3, 1, 2, 3, and we'll go calculate, and we get a circumference of 584,336,233.5677. So I'm just going to copy that, put it into my calculator, put that, paste. Oops. Can you do Control V there? Okay. Now I'm going to divide that number, which is, I can put this where you guys can see. Can you see that? So we're right there, 584. We're going to divide that by, oops, where's my calculator at? Here. Divide that by 365.2. I don't know if it's 0.25, 0.24, or whatever. We'll just put 0.25 for now. And we get that, and we're going to divide that by 24, and we're going to get 66,659. So nobody is being deceptive, no matter what they tell you.
What was the
It's an
answer?
actual number, 66,659. So when we say 66,600, it's not that we're making up 666 numbers or that we're just arbitrarily throwing them in. That is the accepted known speed of the sun, of the Earth around the sun. So just what I find with Globers is that they always want to claim everybody else is lying, everybody else is being deceptive, and they're just never off. They're just everything they're right about. It's like, no, you're wrong on a lot of things. I had one question about something that was on your site here. Speaking of, well, you can comment on that if you want. But I think that a problem I see, McToon, is that your audience trusts you a lot, believes you a lot. Meaning that when you say something, I hope you realize that it carries with it the fact that those people who watch you don't really do much research, whether you realize that or not. We may not realize that as creators because we do research, we're looking into things, then we present it, and it's almost like in our mind, we think that these people have gone through the same process, and they haven't. And I know that it's true of flat earth believers. I know that that's true. I know that it's not safe for me just to go on my show and say anything, because if I do, those people might believe me. And maybe that's because I've created a track record that they should, or whatever reason they believe me. So I actually look at that and I think about that before I say things. Whereas I'm not sure that Globers do. I don't think that they care, that they're, that even like now when I say that, you'll just say like, well, no, but it is just an average. You are just grabbing that. Okay, you can, but to make the claim that people are being deceptive as if they're sitting around, what should we call the speed? Let's call it 66,600. No. If the math came out to 66,400, then we wouldn't say 666. It's just not what the math comes out to when you do the average. Go ahead.
All right. The timer wasn't going, but
yeah, I saw that.
The time went fine. So your number came out 66,659, not 66,600. And if you round it, it's 667, round it to 3 digits. So it's still not actually the number, but it's a range. What's that?
I think they said, I don't remember what they said, but they didn't say 66,600. They said 66,006 something.
Yeah, I don't remember exactly what
Maybe
they said.
Maybe 616 is what I kind of remember. I don't know.
But I've had several hundred debates on here, and pretty often they bring that number up. And typically when I hear it, they just round it to 66600, which of course isn't 666. It's 1,000 times more than it, but it's not the average. It's not the fastest. It's not the slowest. It's one of the numbers within the range that was selected because it has a certain meaning to somebody. But as if, and this is the real problem then, that number was somehow selected as if it means something, as if the people that somehow caused all of these things together to output that number.
Could that not be the case? Let's say
that could definitely not be the case.
Why is that?
Because it's just a number within a range, right? How fast did I drive to work? Did I drive to work at 66.6 miles an hour? I did not. I drove between 60 and 70, and at one moment or multiple moments, I was going precisely 66.6 miles an hour.
But if we took your total trip and we divided that by the total time to the exact number, and it was that number, then that would be different.
If it was that exact number, yes, that would be different. But
Well,
if it was
the exact number is having 666 in it, 66,006, whatever.
but how is that evidence for something?
It's not. I think it's an interesting point. I mean, would you find it to be if we came out and started talking about flat Earth and you started looking into it and found, oh my goodness, the originator of flat Earth was a former SS Nazi member who the United States government brought over here against the knowledge of the United States citizens. They didn't know. It was a private thing that got leaked out, years later. And then people had to kind of accept it and suck it up. But there was over 1,600 Nazi high-ranking level members of SS that came over, built these bombs, built these missiles, and then became the heads of NASA. So if the roles were reversed, you would totally have a problem with it. You guys would totally say like, oh my God, flat Earth is a joke. Do you know who started it? Nazi members.
Well,
But because it's your world, it's because then we just accept it. We're just like, oh, well, it happens.
Definitely a lot of people reference that there are a disproportionate number of those kinds of people in the flat Earth movement. Dubé specifically.
Okay, so you have a problem with that, right?
Yeah, I don't say, but I would not say Earth is not flat because of that.
Well, and if you
Right?
heard somebody say
That's
Earth
not
is
an
flat
indication
because-
of the shape of the Earth.
Yeah, but has anybody ever said the Earth is not a globe because 66,600 miles per hour?
They use it as part of their case. Absolutely.
Again, wouldn't you use it as part of your case if you found something like that has some connection? Because you have to recognize that many people who believe in this, and it may not be.
I already don't. I don't say Earth is a globe because Eric Dubé likes Hitler. I don't say that. I already don't do that.
I don't
right?
say it either, but I do think that it's an interesting number that happens to be the Earth going around the sun, and you can start to say that a lot of people believe that there's some sort of sun worship going on by these ancient, whether it's the Babylonian cults or the Chaldean, whatever, that maybe are still around today, the Egyptian connections. And so when you get a number like that tends to, now for me, I have a totally different belief, right? I believe that number is used by people in positions of power in order to get people onto the side of belief. That's just me, my personal thing. I'm not Christian like most flat earthers, so I've got a little different opinion of those things. I think that it's all part of a master kind of deception. That one of the things that they use is if they make Monster Energy drink and make it a 666, say it on the back of the beast, right? Or if they do these kind of things where they keep referencing that number, what it does is and I've heard people say it to me, well, Jaron, why would the elite worship Satan? Why would the elite believe in 666? Why would they do that? So to me, it's like, well, they want you to think that they do. Whether or not they actually do, I don't know. I'm not behind closed doors. I don't know if they're actually sacrificing babies. Don't know that. I've heard that they might.
I don't. I'll just say, okay. There's a long list of things that I could put together and build a meme of here are the people that think the Earth is flat, and here is the different things that are in there. But I actually did create a meme where there are a bunch of 666s in flat Earth as a joke, and sometimes I put that around as a joke, but it's just a joke. So anyway, okay. Our time is up.
Yes. Go ahead. You can start the next topic.
All right. I'm gonna share my screen. So let me get over to Zoom here. There you go. All right. So you specifically, and you have a point, said that hold on, I'm fixing the scene here. That a lot of people don't do their own research, and you're right. Not everybody can go and do the things that. Yeah, I get that. You can't. I don't think you can expect that. I think that people are experts in different topics, and they're gonna be they're gonna work on their topics.
Watch us, right? Because maybe they don't have time.
Yeah, and
research, and they expect us to.
I've taken it to heart when you've mentioned this, and I hadn't thought of it, that people believe me. And even if I say, don't just believe me, you should definitely be, be checking things out for yourself. People still will. And I know that flat earthers do that. So as well. So it goes both ways. So I have done things myself. I prepared this. This is not something I specifically did myself, but it's something that one of us did ourselves. So it goes straight to that point. So is the timer going? I can't see it.
Go ahead. No.
Okay. So this is from Res Rhetoric. This is his elevation of the ISS measurement. And I don't know if you've gone over this. It involves a little bit of trigonometry. This is about high school level trig. And of the, I hope that this isn't too far for most people. I think if you don't use trig, it gets super rusty. I get that. I wouldn't expect people that don't do trig to get it. But saying it's not right just because you don't want it to be right, of course. And Jaron, I'm not saying you did this, but that's not the correct way to have a response to this either. So anyway, this is simply screenshots from his video. This is the diagram of what he and Astronomy Live did. You'll see that the angles A and B are the same amount. This does not use the distance to the moon at all. It only uses the angular size of the moon. So and it also doesn't use the actual diameter of the moon. So no specific information about the distance or size of the moon are included in this, just the angular size of the moon, which is 0.52 degrees. So here is the simultaneous tracks that both Astronomy Live and Reds recorded as it went across the moon. One of them was a P900 or P1000. And the other was Astronomy Live's telescope with a camera on it. Then they measured the actual height in pixels of the moon, and then measured the height in pixels of the gap between the two tracks. And then they get a ratio from that, right? 962 pixels tall, 224 or 224 pixels between the tracks, giving 4.29. And that 4.29, then they plug in, and there's no screen or no screen for it, but they take 0.52, the angular size of the moon, and divide by 4.29 to get this. Then outputs the degrees between the tracks. So that's this A equals 0.1212. So if you do the math yourself, you'll find I confirmed that myself. 0.1212 is the angular size between these two tracks. That's what that number is. Then they got the distance between them. This is the Google Maps that shows the distance between their two locations, 1.11 kilometers. And then you can create a triangle with that. Now this isn't the height yet. This is the distance to the ISS of the midpoint of their base there. So they cut the triangle in half. The 0.1212 turns into 0.0606. They know their baseline is 1.11 kilometers. They cut that in half to get 0.555 kilometers. And there's all the numbers. That gives use the trigonometry here is what you need to use. That gets the distance to the ISS from their location of 524.73 kilometers. Now that's the distance from the ISS.
And that's with no no spherical mathematics included as far as adding the curve between the two people?
Correct. There's no curve between the two people involved. I'll show that. This is just the picture, right? So the distance. Yeah, the distance they did is 1.1 kilometers. So the chord distance versus the distance, the arc distance is going to be very nominal. It won't change the output much, but certainly anybody that was interested could do a different, right? This Google Maps uses the Haversine formula. So this is definitely the curve. And so somebody could do a chord distance if they wanted to. So
Okay.
It's going to be buried 4 digits deep probably.
Can you bring back the image of both them crossing the moon for me? I just wanted to see, did it look like a angular size difference there? Quite a big one from the one on the right versus left?
The angular size of, yes. So this was 2 different cameras.
Okay.
Yeah.
So if one of them is almost half the size of the craft itself, how could you compare pixels and compare distances? I don't understand why the moon.
They're not significantly different in size. It's that one has a different frame rate, and I think that they're closer together. So maybe the ones on the left look smaller because of their proximity to each other.
Possibly.
So, but yeah, I mean, we could look at this. I don't think that they're drastically different in size, but it's a good point that we can.
No,
look
and
at.
I'm just trying to think if it's that simple, but that's something I'd be willing to do. Is it help us to have a larger baseline? I know we need the ISS to cross the moon for both.
Yeah, and yeah, as you get farther away, then you're going to get a smaller stripe across the moon, because it'll be closer to the edges of the moon.
Oh, gotcha. Okay.
But yeah, it can increase precision a bit. So, yeah.
And then you're not taking the distance to the moon you just are taking the fact that it's a certain angular size.
Yeah, it's 0.52 degrees. Now, yeah, and you can measure it yourself. And Reds makes a point in the video that Astronomy Live shows in a different video how to measure the angular size of the moon. So there's techniques to do that. You can look it up if somebody didn't trust this number, they can confirm it themselves as well. And like I said, Astronomy Live did that, but didn't want to get into it for this particular talk. So anyway, so
write that one down. I will check into that and see if I can replicate that.
All right. There's just a couple more. I don't want to get too far into this before. I don't know how. I don't see the timer, so
it ended, but I'll give you another.
I'm almost done. All right. So the distance from there, and it's from the midpoint between them, is 524 kilometers. So then you need to get the height of it. So this is off of the telescope that Astronomy Live was using. It was at an angle of 53 degrees. So he turned off the tracker, the mount, as soon as the ISS passed. So it stopped moving the telescope, so that he was able to measure this 53 degrees. So then this is the actual like altitude calculation, right? And he's using a flat baseline here. Now he does also do it with a curved baseline. And so you can do it with both of them, and it's going to make a difference of a 3-4 digits deep in the calculation. But you certainly can compare the two to see if it makes a difference that matters. And I've looked at it; it does not, but I don't have those numbers in here. Anyway, so we have the distance to it, we have the angle to it, and so this is just, again, trigonometry, SOHCAHTOA. This gives you the altitude when you take the 524 kilometers times the sine of 53 degrees. You solve for the opposite side there, and that gives 419 kilometers high. So this did not use anything from trusted from somebody. This was confirmed personally. The size of the moon in angular size was the only thing related to the size of the moon used, and of course that can be done yourself as well. So there you go.
Okay. Yeah, I mean, for me, as far as seeing both the sun transit and moon transit, something is crossing it. And whether or not it would calculate out to what they said, I would expect that pretty much. I will just bring up this real quick. So in one of your videos, or I'm sorry, one of the links on your page here, you have, oh shoot, is this thing not going to work? I'll just have to do it like this. So move it over there. You won't be able to see you for a second.
Are you gonna share something?
Yeah, just real quick, but I can't figure out where the screen is.
I'll stop my share.
Yeah, please. Just I wanted to show you this. This is from your site, right? You said, thanks, Sharon. Good old Bryant Myers. Gus made this image, which is like really dumb. I finally saw it. Thanks, Sharon. It's like, this is what people think is funny, but I don't find the humor in it, because it's me really actually going out and doing something that people always say you don't do. Oh, why do you hide these videos? Why do you? I've never done any of that. I got 2 strikes on both my channels from Bart Cybrell, and I had a choice to make: either leave all my videos up and take a chance at losing the channel that I spent 7 years building, or take down all my videos, wait the 2 or whatever it ended up being 90 days, and then start loading videos again, and at least keep the channel and keep the sub count. So that's what I chose to do. But then all I get from now is people saying, "Oh, you deleted his ISS footage. That's dumb. Why would I ever post it? Why would I post it and then delete it? Why not just never tell you that I did it?" But again, people are they like project or something, I guess, because clearly there was no ill intent. It was on my channel for years.
Could you scroll that again? You weren't on. It wasn't on screen when there it is.
Yeah, so there's this one. And I don't know who made this little fake thing. That's not mine. But one thing I thought was funny is that up here you put, Jaron recorded a video of the ISS passing in front of the moon, confirming that it is orbiting the Earth. So is that really confirmation?
Well, you'd maybe need another couple things to confirm that it's orbiting the Earth, but
right. So I mean, this is the problem, is that it's when you're going to post this and people are going to read this and they're going to say, "Oh, Jaron, you confirmed it." Well, no, there's videos of planes crossing. Here's a video of a plane crossing them. Now, did this confirm that the plane is in orbit of the Earth, or did it confirm that a plane flew in front of the moon? So all that I've confirmed is that something that they call the ISS that seems to be shaped like it is crossing the moon at the time that they say. Now, I've told people, because people always say, "Oh, well, how do you know everybody else is doing it? How do you know everybody else is seeing the same thing?" I say you don't need to go further than just yourself doing it, because as long as you don't tell other people that you are doing it, and you go to transitfinder.com and you put in, wherever you want to go, it can not even be near your house, go wherever you want, and you go out to that place at that time and you watch it cross, then you can by de facto assume that anybody else near you, the people after you, the people before you, could all have done the same thing. So something seems to be crossing the moon in some when they say. Again, is it happening over water and all these other things? I don't know. We can't verify that. Could just be. But again, I'm skeptical of these things because I do think it's a deception. So I look at everything. I don't just accept. That wouldn't be the way to uncover deception. Would be to, there it is. It's exactly as they predicted, and therefore it must be true. Well, no. If it's a deception, then you would expect that. You should expect it to be what they want you to confirm with it. Not, I don't know. If you put out, I don't know how to explain it. I always talk about it being Christmas cookies for Santa. This is what Globers fall for, is that when you put out cookies for Santa, the kid sees the cookies go out, the kid goes to bed, he wakes up the next morning, and the cookies have been eaten. And therefore, in his mind, he says, well, that means that Santa's real. And this is what Globers do, is they're given the answers to these questions. They're given like numbers to plug into formulas. And then they're like, oh, when I plug these numbers in, look at it, it comes out to exactly what we expect. Yeah, that's not evidence of anything. That's cookies for Santa.
But it's more than that, though. It's not just, this isn't simplistic like cookies, right? These are things that somebody that is not NASA took data from NASA, said, well, if NASA is correct, then we must see the ISS on this date in this location, right? The Transit Finder isn't a NASA website. They're just taking the data that NASA publishes about it, right?
Correct. Yes.
So, and then when you say, well, here's where it's going to be, then somebody goes and says, well, I'm going to go grab the orbital mechanics application. And I'm going to say, well, where will the ISS be according to that data? And according to orbital mechanics, it will be here. All right, well, let's go confirm it. Well, there's your science. You have a hypothesis, you test your hypothesis. If it matches observation, then it's confirmed. And if it doesn't match observations, then it's disconfirmed.
Right. And well, we can get into that later, but and should be thrown away, really, right? Not just made placeholders for and
all right. So when something's disconfirmed, there's a whole lot of different ways that you can respond to it, right?
Sure.
And things are valid and things are invalid in kind of how you might do it. But you definitely, you're going to circle back and you say, well, my hypothesis was wrong. The things that we thought were going to be the case were not the case. So what's wrong about it? Well, let's take some of the the data that we collected before and feed that back into our understanding and improve on our understanding, all right, we can form a new hypothesis and go back around.
So how would you ever falsify the globe if anytime something is put forward that it's just kind of, we can cover up, we can put some math in there, we can put some placeholders, we can call things dark energy, dark matter, we can assign things weights to neutron stars. A teaspoon of neutron star weighs 21 billion pounds.
But that's not the globe. So how could you
it's all part of
falsify
the
the
same
globe, right?
Well, yeah,
So-
but I mean, all that stuff is just made up. How do you think they figured out the weight of a neutron star? It's what needs to work in their mathematics for their story to work.
It's physics. They didn't
There's
just
no physics of neutron stars, McToon. Come on. What
Yeah,
is the
there is.
physics of neutron? What do you mean? Who's gone out and tested a neutron star?
you don't have to go out and test it to have
Oh,
the
so physics
behind
is
it.
just made up stuff in the sky?
No, it's not.
Then what is it?
People develop an understanding of how things work, of how the physics of particles work and high energy particles. And
It's such a belief that, yes, I know people go to school and learn what a neutron star is, but nobody knows what a neutron star is. It's just what needs to be for their mathematics to work.
yeah, it's a hypothesis, and and they do things to test it. And
How can they test
if
the
there's
weight?
new information, then they'll adjust it if it doesn't match. So how do they do? Well, all right, neutron star. I'm not an astrophysicist. That's not my speciality. But if you want to talk about how do you falsify the globe, I can do that.
Okay.
Right. So Professor Parks is in the chat. If you want to talk about neutron stars, he might be a better person to ask about how they test a hypothesis for neutron stars. But you asked, how can we falsify the globe? And there's
Right.
definitely ways that we can falsify the globe. Right. If the distances between lines of longitude south of the equator increase instead of decrease, that would falsify the globe. If
Right,
things
but that
are
wouldn't make any
not
sense. That's not longitude and latitude. That's not how they work, right? So that wouldn't.
well,
that would be the case.
hold on. I'm giving you a list of ways that we could falsify.
That's what you just gave me as a pretend thing that would never happen, because the globe describes what the longitude and latitude is. So how would they get bigger after the equator? That doesn't then no longer is a globe. Therefore, what do you mean? I mean that
that
I
would
want real
falsify it.
examples. Yeah, but the globe has been designed with those longitude and latitude. And by the way, those maps had longitude and latitude in the 1500s, 1600s. It's funny that you all these people talk about, we went out and we did these surveys and we surveyed this land, we surveyed the triangles and but we need
Latitude, longitude is something that you don't even need to do anything to say, well, on a sphere, we can do the spherical trigonometry, spherical geometry for it. You don't need to actually go anywhere to say, well, a sphere will have this. It's how the geometry
sphere
works.
Right. Okay. That's what I was saying. That was my point. But we're told like this story that they went out and they did all these crazy measurements and they, did these, the great, what do they call it? The, what's the one you always refer to?
The transcontinental triangulation in America, arc of the parallel.
Yes. Right. I mean, we were told this story like as if it's, what were they even doing? They already knew longitude, latitude. If they wanted to know the distances between two places, they already knew it. They already had that.
So
they already had that information.
No, they didn't. They didn't have the linear distance between them. They had the angular distance between them. So all right, I have to adjust something here. Somebody's saying this. I need to update my slow mode. It's too fast.
Okay, and then
all right. So
another thing.
Let me give you at least one more for falsifying. I'll go back to early. Aristotle is attributed. It may not be him, but Pliny. I think Pliny the Elder is the one that gave him credit for it. Was said that things get obstructed bottom up as they are farther away. Now, whether or not Aristotle could actually do that, I don't know, but I can, because I've done that with this. I've seen things far away be obstructed bottom up, and that's what the globe predicts. If things were not obstructed bottom up with increasing distance, then that would be a problem, and so it's been confirmed that way instead of disconfirmed. So there's a second one, just to.
And I've heard you say before too, which I think is kind of disingenuous, that you can't imagine a mechanism by which things would disappear bottom up on a flat Earth when it's been shown, it's been talked about a million times. Even today, driving from my home down south here in LA, I saw these distant mountains. I don't know which mountains they were, very far in the distance. And I told my wife, I said, look at those mountains themselves are disappearing bottom first. And what's crazy about that is that the bottom is closer to us than the top of those mountains, right? You're going to have an angle going off, but it's just because of the way the atmosphere works. Where am I looking through the most amount of atmosphere? Down low. Where am I looking at the least amount? The top of the mountain. So it makes totally sense that you would start to lose the bottom. Another thing I saw you say the other day in one of your videos, you were showing an eye chart. And you were going on and on. I thought you were so off base. You were like, oh, well, flat earth belief is that eventually these letters will disappear. And you're like, but they don't disappear. They just get smaller. But you're like, no, our position is that eventually those letters would disappear as they would. If you went down more and more rows, where would the letters be?
Why did they disappear?
Because they got too small to see. You were showing the chart right there. And you said, you pretended like, oh, the globe belief is that these letters will just get tiny and then they'll stop. And you're like, but flat earth thinks that they'll get invisible. Well, they would.
They wouldn't get invisible.
What do you mean? If you go show the eye chart again, as you go down and they get smaller and smaller and smaller and smaller, eventually they would disappear.
The really small ones, but my chart, my chart was not showing that. And my point of that, if people may not remember, was that if you look at a building, the building, it's a vertical building and the entirety of the building is almost nearly all the same distance from you, though the top is slightly farther away from you than the midpoint, the same elevation as you. But the part below you, so if you're looking at a building, like I did with this camera here, looked at a building that was 30 miles away, I think, I don't know how many exactly miles, and you only saw a portion of the building. So let's say of a 30 floor building, I saw floor 15 and nothing below it.
You saw nothing. What was it?
I didn't count. It was blocked by the water. So there's water and then building. So the amount of atmosphere at that intersection between floor 14 and 15 isn't so much thicker that instead of the blurred portion of the building with slightly more blur than level 15, there's water, just like water with crisp edges to the waves. That's what I'm talking about. That's what we see instead of, if it was more atmosphere, we would just see more blur. And if it was then floor 13 would be even more blur. Right.
Now, rarely, doing it over water, I've seen that, but I rarely do I see anything over land kind of show anything like that. But I guess it would be very difficult to find.
You don't know the topography of the land. It's
right. Which would be interesting to see, because I do think what's happening is, in that particular case, if you picture, and I've shown this before with a magnifying glass, that I laid down basically a blanket on the floor, blue blanket for, maybe it was 8 feet. And at the end of the 8-foot blanket, I put a building, just a little cardboard building with like 6 windows. And then I put a magnifying glass down in front of my eyes at the edge of the water, looking at the far distant building. And the building is halfway covered with the blanket, because the magnifying glass is magnifying what's right behind it, which is the water.
You did Skiba's. You did Skiba's thing. You use the magnifying glass that bends light the opposite direction that it does in the atmosphere. You need to use the top half of the magnifying glass. So cut the magnifying glass in half and then put it down in front of you. That's what you need to do. I did it. I haven't done the video yet, but I did it. I bought Skiba's thing.
His kit, so did I.
And I have it back on the floor behind me. I have in my kitchen table, it has leaves. And so I actually opened up a little gap, and then I put the lens so that it's halfway, right? Because there's enough of a gap.
Why? Because you want the atmosphere to bend light which way?
The atmosphere bends light down. And so the top half of a lens, as you're looking at it, will bend light down. The bottom half will bend it up.
Okay.
So I dropped it down so that the lens would do an analog of what the atmosphere would do. It will bend light down.
So if light bends, if the atmosphere bends light down, but you're saying bending light down makes it appear higher.
Yeah.
That's your position there as far as that goes. So what about when I showed looking through a tank of water and showed that it actually is dropping? Why do we see that? Why when we show a pencil, if I were to take a pencil and put it in a glass of water, you would see it lower?
Well, the curved front of the glass is a whole different thing. It's not the analog to the air. You need to set up something that's an analog to the air.
Okay, so if we got a flat glass, it would do that?
No, you need the gradient. The water isn't really at a gradient. You tried this yourself, right? You got a tank, but we didn't quite get it.
So let me ask you this though.
Set
Again,
up right,
so like,
right?
I wanted to talk about the Stephen Hawking documentary, just real quick on one particular point, is that they were so gross. And I mean, there's no way Stephen Hawking, the real Stephen Hawking, was involved in that at all. It was so grossly done that either the man is incompetent or an invalid, and they have somebody else speak for him. Because what the tests that they did were not tests that any scientific-minded person would ever allow or show or want their name attached to at all. They actually said that a helicopter hid behind the curvature of the Earth at 6 miles, and they did they didn't even like show you the calculations, but it's hilarious because at 6 miles the curvature formula calls for exactly 24 feet. And so they get in this helicopter and they lower down, and the guys with the telescope, and he says, "I can't see you. Are you guys still flying?" They're like, "Yeah, we're still in the air." And then they land, and then they take off again. And he's like, "Okay, stop. I'll tell you when to stop when I see you." And then he says, "Stop. Okay, I see you. What height are you at?" And the guy looks at his altimeter and says 24 feet. It's hilarious because what they forgot is the fact that the guy with the telescope is higher than the ground level. So actually he's about 3.5 foot tall. So the amount of curvature over 6 miles is like 8 feet. So did a helicopter hide behind 8 feet of water? It's impossible that a helicopter would ever hide behind any water at 6 miles. The fact that anybody believes that is just a testament to how truly
all right,
out of it people are.
That's a documentary. You know that.
Well, it's a documentary.
It's not it's not a peer-reviewed, published scientific experiment, right? So it sounds like
why lie?
It sounds like your issue is, and I agree with you, is that it should have been done more rigorously.
It's just, if you have to tell a lie, for instance, let's just go to Behind the Curve. They had to
hold on. I have to have a drink first. Just a second.
I'm surprised it's not spelled a different way, to be honest with you.
It's my ball mason jar.
Yes, you're a big fan of balls. I got you. All right. So with the Behind the Curve, now this might only be true for me alone, is that Behind the Curve is one of the biggest evidences for me to go, oh shit, if you're going to do a video about, or you're going to do a documentary about the globe, flat Earth, and you have to lie, you have to put an out of sequence experiment at the end, and you have to make it look like something. And again, for people who don't know, I went to a lawyer and said, "Hey, do I have a case here?" And he took all the text messages and everything. And he said, "Well, you would if they would have made one mistake, which was saying at any point that you proved curve. Do you have any evidence of them anywhere saying that?" Mm-hmm. No. Is the scene that they showed at the end, is it an actual scene where you actually said that in real? Yes. You have no case, right? He said they're smart enough to know that they can't have done that and then said in interviews or other places, well, he did prove this because now they've placed that on me, and I could go back and ask for the footage showing that, no, there was observations before and after. And I've actually showed the email from the producer who says, oh, there were many observations. There was ones before that showed both flat and curved, and ones after that showed, but there was only one that showed just a curve. Well, what does she mean by that? That we're doing observations of each different view. So what do you mean there's, okay, well then why not take the one that showed flat and just say, oh, there was only one that just showed flat, and then forget about the others, which is basically what they did. They took the others out of the video. And then here's why I think that's so funny. I think it's more indicative of Globers being so hypocritical, right? So if I were to come forward and say, hey, I did this observation across 16 miles and I saw no curve, and here's the flat. Immediately, every Glober would come at me and they would start demanding. Oh, they want to know the temperature gradient. They want to know the refractive index. They want to know what the weather was like. They want me to do weather at different heights, everything. But if I say the word interesting, that nobody asks a question. Jaron proved curve. So this is a absolute, it just shows me, it's like, oh, so you guys are not looking for evidence. You'll call anything evidence. Me saying interesting in a hit piece movie, you'll call that evidence. But when we bring forward anything, we can go on and on about sun flashes, mirror flashes, and nobody will listen because they want to know every fact that goes along with it, rather than just recognize the fact that you can't see mere flashes if there's a mound of water in between you. But nobody will listen to that, and this is the problem. We'll never get anywhere. We'll never uncover anything. We'll never, because you guys are protecting
Well, all right.
the very people we're calling liars.
Jaron, I started with this is like the response to it, but the step-by-step measurements of the height of the ISS. Right. That's what this is the discussion to follow that.
Sorry, we still on that.
It's gotten kind of long, I know, but so you can't say we're never going to make progress. It's been done, right? Somebody did the actual analysis of it. And I did, I did this video a while ago. It's the one I took down at your request because I got a few things wrong about you. But in that video, I point to the video that Reds did where he measured the height of the ISS. So, and I know you can't do it right now. It's asking too much to say, look at it right now live.
No, but that's something I will look at. And because sometimes I need to think about something too in a, not just in a spur of the moment, kind of make sure that all the pieces that are coming in are not derived, that are not set up for us in a way that, that, because this is what I find Globers do all the time, is that they'll make it seem like something works. But then when you actually go look at it, you're like, well, wait a second. Like I get lost all the time when I try and, who came up with the distance of the moon? Who came up with the distance of the sun? Every Glober has got a different answer. They don't get it. They don't get the
for who did it,
who or when or what or Venus.
But none of that matters. You can measure. You can measure it yourself and see if it's even right.
How would you measure the distance to the sun?
Reds just did it last week.
Okay, with what? With himself?
What's that?
With him and another person? What do you mean?
Yeah, him and Astronomy Live.
Okay.
Did it. He drove from where he lives in Florida to Colorado so that him and Astronomy Live could simultaneously see Mars. They use Mars to do it. It's way out of scope for this conversation.
Now you're using Kepler's laws, and so these things didn't even exist back in the day. I'm talking about from an originating position.
Say it's all nothing. Say all of the history is nothing. You can just go measure it yourself. So ignore everything. Ignore any historical measurement of the distance to the sun. The distance to the sun. Ignore all of that and do it yourself. That's the invitation.
Okay, that's great. So, you keep saying that now because your audience is going to hear you, and then they all go, "Yeah, just do it." But then when we confront them and ask them how, none of them know how. So I'm asking you.
Reds did a step-by-step.
I don't care how Red did. I'm asking you how. I'm asking you. You're the one here claiming that we can all do it. Anybody can do it. It's a second grade math.
Yes.
So how?
So it's out. We don't have time to go over it right now. We have 15 minutes until this is done.
Okay. So
I will say, just like I did go over the step-by-step of how you can measure the height of the ISS.
I saw that.
If you want, we could go over a step-by-step how you can measure the distance to the sun using that same technique that Reds did, or some other technique, things that people could do themselves. Right. So okay. Anyway, we only have 15 minutes.
The ISS, you're saying the same technique that they used for the ISS, but that didn't determine the distance of the moon. It determined the distance of the
No,
ISS.
it's not the same technique as the ISS.
I thought it's okay.
Trigonometry is involved. But.
So I know we don't have a lot of time, and we could do this again. I would like to have a little better time. I had some things I wanted to line up, and then today went to hell. But actually, if you got to look at where I'm at, I'm ecstatic. But what about left-right curvature squishing photos? Will you admit now that is not evidence of anything and should be removed from your website?
No. I think it's you're talking about the one from Ibiza specifically that Rory did, right?
I'm talking about any person that takes a photograph of anything and then condenses it right to left. Here's what you have to remember is if there's any change, for instance, let's say you're at pixel 100 high on the left with the horizon line, and you're at pixel 103 high on the right.
Yeah.
When you condense that, you create a curve because it can't get from the... Yes,
it doesn't create a curve. It creates a diagonal line.
So let's say that there's...
a straight diagonal line.
No, I don't think so. I can do it real quick and just see. But If
All
you're
right.
talking about just what pixel change you want, 3 pixels? Where's my? I don't think that that's the case. And we've shown before that it can do both, right? So, and it's because you'll never take a picture straight on. And if you did, then you would have the same pixel on the left and right. It can't be different. How would it be different?
So
And then when you condensed it, like that's the worst thing to me that why this is one of the things I'm talking about. Why would this keep being an issue? Why can't
okay,
we as
do it.
go ahead.
You could do it now. You're fast at this.
Okay.
Create a thing in what do you use? Paint something.
It's called real world paint, but for some reason
Okay.
it's just
So create a line that's one side, 3 pixels higher than the other, and then do a left to right compression. But make that line straight between them, and see if that creates a curved line or a straight line when you compress them.
Oops, sorry, I lost you here. What did you say to do?
So make a straight line across your.
Hold on, something's going on with my computer here.
Yeah, I don't see what your program is.
For some reason, it won't bring you up. It's in the taskbar, but let's see here. Stream Deck is there. Okay. I don't know where you went. I'm not sharing my screen. Zoom.
I see your desktop.
Yeah, and I'm clicking on Zoom. It's just and this is all screwed up because I'm not at home. So this is my calculator. If I open that, that opens. Okay, and then if I go here to Zoom, I just click on it. Nothing happens. And I'm minimizing OBS, minimize Telegram, minimize Stream Deck. I don't know where it is. Let's see here. Why would I lose your Zoom? Let me try this.
You had something up before.
Yeah, I had you up. It's just not coming up now. There's like not.
Okay.
Let me try this Zoom here. Let me just go here and try it again. Just open it again. Oh wait, I'm the person who started the account. That won't work. I was gonna say I'll just make you if I have to.
People like your nebula next to a spherical planet desktop.
Yeah, it's pretty, huh? Oh, don't get me wrong. Space is fake, but it's pretty. When you get these, data visualization artists who take black and white basic.
All right, don't get distracted by me. Sorry.
Yeah. No, so I'm gonna real quick. I'm just gonna duck out of this just to get that zoom back. Let me see. Right, tune and why did it say join? It's like okay, there you are. That's so weird. I hit join. I was obviously talking to you. Obviously,
all right.
Join. Okay, so let me bring OBS back up. All right, now we got that. So now let me see if we can get this up. Close window. What happened? Am I there?
No, there's 2 of me on my screen.
Why is that?
Because I'm presenting what you're sending me.
Oh, I'm just trying to open this paint thing program, and it will not open. I don't know why that is. It's just not working today. Just everything doesn't go anywhere unless I wonder. Oh, you know what it might be? It might be because I usually have 3 monitors, and I only have 2 here. I wonder if it's
Slumming with 2 monitors. Oh.
I know. I don't know why it just flashes when I click this. All right. Anyway, so if I've shown people before on my show, and I've shown people on your website itself.
But you can't get the program.
Hold on, let me see if I can get this to come up. Now I've got 2 of them open on the taskbar, but they just don't show anywhere. Let me try and open an image from your website. We'll try that. So let's go
just create a blank document in.
I tried that, and when I open the program, it's just nothing's opening. But if I try and open like an image, sometimes it'll open from there. Where is that at? On your homepage, right? And it says left, right curvature somewhere. Left, right curvature. So, but you recognize that those cannot be a correct test unless you were to go in and make sure that the pixel height of the left and right are correct.
No, I don't.
Identical.
It's not a test of level. It's a test of straight or not.
Right, but if you were to take a picture of the horizon and it was straight, but you slanted it,
it'd still be straight.
The picture slanted.
Yeah, it'd still be straight.
I don't know how you.
A diagonal line is straight. It's not curved.
didn't you try this? Didn't you see your kitchen table, your chandelier, all those things were curved?
That was with my camera on my phone, and that was because of the pixel alignment actually. And
Is that what I just
it was quite, to borrow a term, interesting that the pixel alignment in a new phone, because there's so many pixels, it's a bit jaggedy versus an older phone, because Rory was using like an iPhone 4, I think. The pixels are much larger and they don't have that problem. But a higher end camera, this is a fine camera for that. I intend to test it with this as well, and hopefully don't have the
okay. So do you have tile floors?
All right.
Do you have tile floor in your house?
No,
No tile floors.
I do not.
Okay, so anybody who's watching this right now, take a photograph of your tile floors, which are straight lines, and run that to an image processor and then squish it, and you'll notice that all of a sudden your entire floor is curved. So that alone should tell you, oh, we cannot use this for evidence. I've already shown.
Right. The point is to.
The point is if you can take a photograph of a horizontal line. Hold on, if you can take a picture of a horizontal line, and then when squishing it, it becomes non-horizontal, then therefore you can never use that as evidence, because I just showed that a horizontal line produces the same effect.
But I'm not trying to use a horizontal line. I'm trying to use a straight line. So a diagonal line can be straight, right? Okay. So the straight edges, and if you have a problem, there's other problems you might point to in there. But if you take a straight edge in a picture and you compress it, you know in reality, in meat space, that straight edge is straight, right? So tiles might be okay, but I used a 4-foot level, which is designed to be specifically straight. So I know that the 4-foot level is straight. And when I brought it into the image Photoshop, that straight line or that straight level was jaggedy up and down, and that told me that the actual pixels in the CCD of the camera were not all physically in line with each other. If you didn't have that problem, and then you took a picture of a straight edge and you compressed it and you saw that straight edge was then curved, then you know that probably it's something to do with the lens. But if you compress it and it's still straight, then you can be certain that the lens didn't add anything, and whatever other things didn't add anything. A straight line.
The only way that would ever happen, the only way you would ever see a straight line, is if the item that you're taking a picture of is horizontal and has a starting and ending pixel the same.
Well, I don't know why you think it matters that it has to be horizontal versus diagonal. A diagonal straight line is still straight, right?
I'd have to see it. I've never seen a picture condensed and then the resulting image perfectly horizontal, perfectly diagonal. You're talking about 1 pixel over, 1 pixel up, 1 pixel over, 1 pixel up, 1 pixel over.
Well, no, that's just 45. That's not perfectly. I mean, any angle. But I think that probably is something that you and I can test, right? I'll get that same level. I'll use the P1000. I'll get some photos of it, and we'll see if.
Okay, because that's the kind of thing I think if we can reach a conclusion where, okay, no longer can that be used, then we're getting somewhere. Then we start to go, okay, let's look for evidence that we can actually.
Right. And from you,
okay,
if I get a picture of it and it's still straight, can I use it?
You're talking about
you're trapping yourself if you agree to it.
Well, are you gonna? I mean, I have to trust you to not just go and keep taking pictures until you find 1 out of 1,000 that does what you want it to do.
Well, you can do it too. You have a P1000.
I'm not into doing that. I'm into simply. I'm looking here at your pictures here and looking at these ones. Look at this is curved. Why is this curved?
Why is what curved?
Why is this curved up?
Because it's far. Yeah, it's outside the. So he specifically was using the center of frame because the center frame has the least distortion. And he had, if you looked at his website, or his what did he? No, it wasn't a website. It was a Google Images cache.
Can we agree that this is not evidence of anything?
No.
Period. Why not? Why? You're looking at things that are straight that we know are straight. The level is straight, but yet it curves.
The center part of the level is not.
You mean here?
Yeah. The right side, you look at the right side there, the top right, you can see that it scoots. No, the bottom part of that stripe there.
What
No,
stripe?
the top stripe, top section.
One?
Yep. And then the bottom right of that section. It other side. There you go.
Here?
Up a little.
Okay.
Up a little. A little right. To the right a little. There you go, right there. That curves up a little. You see that, right? Right on that bottom edge, that does curve up a little. And so that area is going to be a little bit more distorted. But the rest of it...
So why do you think it's distorted?
That's probably lens.
Well, yeah, not probably. What else would it be?
Yeah, I don't know anything else that it could be, yeah.
Right, so I mean...
But Jaron, like you, I've been I couch all my words, right? Probably lens means I think it's very much likely to be lens, but I'm not certain enough to say it because I didn't look into it enough. So
yeah, I mean, to me, it's these things are obvious. We should be able to move past them and at least say, because I mean, again, I've already shown easily when Sean and Red's Rhetoric did that, when they took a drone up and then took a picture of the horizon, which is an apparent position, which is hilarious that why would we ever, it's like, how is that scientific? You've got Globers out there saying like, let's measure this against the horizon, against an apparent position. Oh, this is good. This is great science that we're doing here, measuring things against apparent positions that we know are not physical. Well,
Jared,
you guys believe they're physical.
Look, I didn't bring that up. I know you want to address it to them, but they're not here.
No.
Right.
Well,
you definitely are free to bring up stuff on my website, but I don't have that on my website, do I?
No, but you have this one, which is probably worse because of the setup with rocks underneath it and the, it's like, what the hell is going on there? And then the other one, I'm just reading right here.
The one that Tommy Gronwald did?
Feel free to download the original photograph and do your own compression. Better yet, count the pixels from straight edge to the horizon and plot on a graph. Well, we did show on my channel that if you draw a straight line across, that it's like 6 pixels higher on the right. So of course you're going to get curvature when you switch it.
On what? Which one is this? This is the Tommy Gronwald one?
The second image, right. And then you said, of course, no flat earther will accept this. It violates their pre-selected outcome. They will claim they don't see the curve, attempt to change the subject, start calling names, run away, make accusations of tampering. None of that is anything I did. All I'm saying is that...
I appreciate that, Jared.
Okay, well, here's the easiest way to do it. Take an image processor on your screen and just do a straight line across. Make it a box halfway through, right? And then take a photograph with your camera of the... this computer screen is not flat. This one is. So if you took a picture of it, you will see that they always...
I can do better than that. I have a straight edge and I have the P1000. So I'm going to do that. Let's table that.
But technically, could a straight edge be bent? Could be.
By definition, a straight edge cannot be bent.
Well, give me one and I'll show you.
But well, then it's no longer straight.
Okay, we'll call it an angle.
It's a curved edge.
Carpenter square. Yeah.
But a level, yes, somebody could, bend a level. They could abuse it and make carpenters.
But this image
cry.
here, you've seen me show that this. I mean, we can tell that if you zoom in here, that by just going over here and looking at the distance between. I'm looking at this light blue, so we're looking at the distance between the. Oops, sorry, didn't mean to do that. Distance between the light blue and like my mouse, if you can see this little, can you see that? Yeah. It fits perfectly right in between there, right? So if we put it right there, you can see it fits perfectly in the light blue. Now, if we move it to the right side and we see that it doesn't fit perfectly now, that it's got extra space on the top and bottom. So right away, we know, just by looking at this, we can peel back and say, okay, well, clearly this side is higher than this side, right? And I guess your claim is that this is a straight line.
Jared, we went over this already.
Okay.
A diagonal line can be straight. It doesn't have to be.
So explain to me then, what are you trying to show here then? You're trying to show that the diagonal line is causing curve? I don't get it.
No, this is showing that the known straight edge in meat space, right? And that's above and below the horizon. The known straight edge, when you compress it, remains straight except for the very far right side on the top. So you could say, all right, we're going to not look at that because it's not in good, it's outside the control. It's not well controlled. Right?
Okay.
But the bottom part,
this right here, you're saying this is a diagonal line.
No, I'm saying that's a curve.
Okay.
The
you're saying
diagonal
just
line,
as
the
much.
diagonal line is the what the straight edge makes on the screen because the camera wasn't perfectly
Where?
horizontal.
Which one? Where is there?
So the bottom. So start on the bottom straight edge on the top edge closest to the horizon.
Bottom
The
straight.
bottom
edge.
left,
Bottom left here.
closest to the horizon.
Okay.
Up a little more. Keep going. Keep going up. Up, up, up. A little more.
These are the bottom.
Is that red? All right. What color is that? Is it red?
Yes.
Okay, so the red part, I'm colorblind. So all right, so the left side, right there, on the left side, right there. Well, you
Well, this
gotta
looks
quit
straight.
moving.
This looks straight. So if you went back and
Okay.
looked at the original image, I'm guessing if we were to take, now that we know that this is looks straight, we'd have to measure it. But if I looked at the pixel of here and here, they would be identical.
Well, or they could be diagonal, certainly. But you can have
hold on.
a
Is there
diagonal
diagonal?
that is straight.
How would it be straight across on the screen if we?
It's not
squished
straight
it?
across. It's straight. I didn't say straight across. Straight. You can have a diagonal that's straight, right? This is straight and it's also diagonal, right?
I don't know. I'm confused. What good that
But
would do us?
is this straight and diagonal?
Sure.
Okay.
You're never going to see that on a condensed image.
So if this was compressed, then you would expect a straight diagonal to remain straight, and a good
I think
camera
that would
with a
clearly
good
show-
lens.
That would clearly show curve. It would clearly show a bowing going like the letter N.
And if you did, you'd know that there's something about the lens or the camera that caused it.
Right. So
Right.
when we do that, when we take pictures of tile floor, get marble countertops, straight lines on computer screens, and then they show curve, then we know it's the lens.
Yes.
Okay, so we need to dismiss all evidence that is being called into play that is the squishing of images if we know that horizontal lines create curves.
No. You
Oh,
only
boy,
need
why?
to
so that we can find the one time that you can claim that, oh no, well this time it actually is real. I mean, this is ridiculous. Like if we know that evidence cannot stand anymore, because how could you claim something is curved by showing its curve when you condense it or squish it? But if I can show a horizontal line also does the same thing, then that invalidates your evidence.
But you need to do that though.
What do you mean? I've done it on my show 3 times. I could do it right now.
All right.
It's stupid.
Let's stop. Let's
Yeah,
Let's
Andy,
do.
you got things to do.
All right. We have homework to do. We'll do it.
We'll do it We'll do it next Thursday again.
No, I can't next Thursday.
Okay, maybe the Thursday after.
I'm going on vacation. All right. So next Thursday is we're preparing to go on a trip, and then we're out of town for a week. So it'd have to be, hold on, the 27th is the next Thursday I'm in town.
Okay, and there's a couple more things at your website I wanted to go over, and then we'll do it the more lengthy one with the questions and answers. I think that'd be fine.
Yeah. All right.
Sound good?
Give me a super chat from your side. You got somebody poking at me? Find one.
I'll check. I have to go check. I wasn't watching that. Let me see here. Let me go to super chats. And is there any for me? Probably not.
Oh, there's a few.
Oh, you can ask if you want. Let me see what we got here. And I'll be a little bit more organized.
You have to be terse though. All right.
I'm staying at a house right now that is $20,000 a month to rent. And I'm here. This is just one of the many bedrooms, and the backyard is amazing. And I'm probably going to go swimming. No, I got to do a speaker's corner first.
All right. Magellan. Hold on. Magellan says, Jared, did you know that the spherical Earth model is built into precisely every electronic device that exists, from smart watches to enterprise database servers?
That the what?
The spherical Earth model is built into practically every electronic device that exists.
So that makes it true?
Magellan. I
People
didn't
not
think
understand that you could cook.
he
You could
didn't
cook
say it was
anything
true.
into a device. Well,
Hold on. He did say it was true.
great. So they take. Yes, I know that on your iPhone, that if you go to the accelerometer, guess what? It says that it's moving 9.8 meters per second squared when it's sitting on your desk. Now, you can be
It's
somebody
not,
who's
no.
so dumb.
9.8 meters per second squared isn't movement. It's acceleration.
Sure. I want to talk to you about that too, because what is momentum? Momentum is the same thing, right?
No, momentum is velocity times mass.
Right. So why can't we call an item falling? Why is that not momentum?
It does have momentum because it's moving.
Right. And it's gaining speed. So we don't need to call
Its
that
momentum is increasing.
Right. So so how is that a force?
No. Momentum. So it helps if you look at the units, right? Force
Let's
is.
not look at units. Let's just talk about practical conversation. If I drop
No,
the ball,
hold on. No, this is very important. Super important. Dimensional analysis is incredibly important in physics. It tells us a ton. So acceleration is meters per second squared. Force is kilogram meters per second squared. Momentum is, what did I say, right? It was mass times velocity. So it's kilogram meters per second. It's a totally different, it's not totally different, right? It's kilogram meters per second instead of kilogram meters per second squared. So it's related to force, but it's not the same.
Okay. Did you ask me a question? We were going to get into something that I went to.
Well, I gotta go. I gotta get going. I got family stuff.
Somebody says, "Good to see you, Jaron." That was one. Somebody says, "Are you done scamming people yet?" No, I'm going to continue doing.
Wait, who asked you that?
I don't know. Patrick Butler.
He's a flurf. He used to be.
Oh, is he? Oh, maybe he's talking to you.
He used to be a flurf.
Oh,
and
there's one of those.
He trolls. He's funny. I like him.
So he used to be a flirt. What made him go back to the Globe?
Bring him on your show. He might want to talk to you. I
just want it to be better than one photograph like Ranty, who spent 3 years going through all these observations, telling everybody how flat the Earth was, and then he saw one picture and was like, "Now I'm a Glober."
You gotta be terse. Give me the best super chat there. Give me something. Come on, people.
Maroon, 1969 film, had HD quality. The Apollo 11 Freemasons who set up the fake moon scenery actually copied this movie a bit. Will you stay asleep? That was the question. And then McToon, do you believe in Santa Claus too? I think that's probably the best one.
Well, there's 4 stages to a man's life.
Okay.
When he believes in Santa Claus, when he doesn't believe in Santa Claus, when he is Santa Claus,
okay,
and when he looks like Santa Claus.
All right.
So I'm in.
You're almost at number 4.
I'm back to step 2.
Jimmy Neutron haircut, you'd already be there. So keep that going.
You like that? I cut it myself. It's
as long as you're in your 30s. You're in your 30s. You're good.
13 officially.
13. Wow, I thought it was.
Hold on, I'm thirsty.
All right, I'm gonna let you go. Thanks for waiting for me. Sorry I'm so late, guys. I'll be back with Speaker's Corner here in a second, and I'll show you my awesome abode.
All right,
we'll talk some.
Thanks, Jaron. We'll see you later.